Geometric sequences. To find the geometric sequences, we need have two formulas. Explicit formula, that is an current term is equal with a1 first term times r common ratio in exponent n minus 1. So the recursive formula is a current term an is equal with the previous term a index n minus 1 times the common ratio. Those are two formulas that can serve us how to find the geometric terms or the terms in geometric sequences. So now just let's make a little bit distinction between geometric sequences and arithmetic sequences. So the formula we are using here, the explicit formula for the geometric sequences, is this sequence here. So we have a common ratio. We have a first term common ratio in exponent n minus 1 for the geometric sequences. So this is the explicit formula. And arithmetic formula is an is equal to the first term a1 plus n minus 1 times d. So this is the formula how we can find the terms in the arithmetic sequences. So now let's go to the next slide and let's solve this. Let's find out about the seventh term. Find the seventh term of the following geometric sequence. So we already know this is a geometric sequence. The first term is 2, second term is 4, third term is 8, and fourth term is 16. So now we have to determine what is the seventh term. First, let's go with the recursive formula to use it. So if we are going here, because a1 is 2, but now we need to find the seventh term. Every time to find another term, we have to find the previous, to use the previous term. For example, now we cannot find right away the seventh term of this sequence. But first of all, we have to find term 5, the fifth term. Now the fifth term here is equal, according to the recursive formula, is equal with so just let me write here the recursive formula, even though we mentioned it, maybe we forgot. And this is an minus 1 previous term minus 1 time is the common ratio r. And now this is a4. So we are looking now to find the fifth term, because we cannot right away find the seventh term, time r. We already see the a4 or term 4 is equal to 16, and the common ratio r is equal with the current term divided by previous term. For example, here is a 4 divided by 2. 4 divided by 2. We already know this is it already states in the question, this is a geometric sequence. And any two terms, when we know it's a geometric sequence, we can take one term divide with the previous term, and we find the common ratio. So common ratio r is equal to 2. Even now, if you take, for example, even if you take 8 divided by 4 is 2. Even 16 divided by 8 is 2. So the common ratio is 2. And now we find in the fifth term. The fifth term is equal to 5. Fifth is equal with a sub 4. A sub 4 is a 16. Let's just erase this number here. Let me write a 16. 16 times 2, which is equal to 32. And now if we are looking for the next term, is a sub 6 is equal to a sub 5 times r, where a6 sub 6 is equal to the fifth term is 32. 32 times r, 32 times r is a 2, common ratio, and this is a 64. And now we can find the seventh term. So as we see here, to find the one term, we always we have to find the previous term in order to get the current term. So this is a sub 6 times r, and a seventh term, or a sub 7, is equal with 64 times 2, which is equal with 128. So here we did a lot of work, but for example, what happened if we have to find a 1000 term, we have to make a 1000 lines, 1000 terms we have to find, or 999 terms until we get to 1000. But here with explicit formula, we already know the formula is equal with an times a1 times r in exponent n minus 1. And now we are looking for the seventh term. Seventh term is going to be a7 is equal. But first of all, let's see, the first term is 2. a1 is equal with 2. So let's just be right here. a1 is equal with 2. And now a7 is what? a1 is equal with 2. The first term is 2. Times the common ratio. The common ratio is a 2. R is equal to 2. And now n is equal to 7 minus 1 is a 6. And now a in a 7 is equal with a, let me write this 7 a little better, is equal with a 2 in exponent 7. And a in a 7 is equal with 128. 128. So if we want, for example, this to check it in calculator, probably you can check it in calculator, but since it's a very small thing here to verify, in exponent 7 is 128. So already we verified here in calculator. So with the explicit formula, we can find right away with one shot, we can find this result. But here we have to do lots of calculation until we get a term of the sequence, geometric sequence.